Hey there, everyone. We're going to work on lesson 5.2 today. I need to take a second so I can share my screen with you. So give me just a second here. All right, there we go. So in the last lesson, 5.1, we looked at indefinite integrals, indefinite. And today we're looking at the concept of a definite integral. So what is the difference? Notice with the indefinite integrals, we had things like the integral of 3x squared dx. There were no numbers at the top and bottom of the integral sign. That's an indefinite integral. A definite integral has limits of integration, has a number at the bottom and at the top. And we are going to define the definite integral to be a certain area when we graph a function. So if I were to graph the function f of x, and I want the area bounded by the x-axis, so the x-axis is always going to be a boundary, the function f of x, the line x equals a, and the line x equals b. So this shaded in area, that area is defined to be equal to the definite integral from a to b of f of x dx. So we're going to really look at this from a geometric point of view today. So let's do an example. How would I find the definite integral of 2 to 5 of x plus 2 dx? So the first thing I have to do is graph this function, the function y equals x plus 2. All right, we can do that. That's an Algebra 1 problem. All right, we're going to go from 2 to 5. 1, 2, 3, 4, 5. That is a line which has a y-intercept of 2 and a slope of 1. So it'd be a line that would go up something like that. Okay. So find a good color here. If I go up from 5 and from 2, that's this area that I am looking for that'll be equal to my definite integral because it said my limits of integration are 2 and 5. So I go from x equals 2 to x equals 5. Okay, well, that is a trapezoid is what that shape is. And a trapezoid, these are going to be right angles for us. If I treat these two sides as the bases, then this is the height. The area of a trapezoid is 1/2 the sum of the bases times the height. So in our particular case, the integral from 2 to 5 of x plus 2 dx will be 1/2. Well, how do I get the bases? Well, this length is whatever the y value is when I plug 2 into my function x plus 2. So this would be the point 2, 4, and this would be the point 5, 7 by plugging into x plus 2. All right, so one base, this base is 4, this base is 7. So 4 plus 7, and then the height is the difference between 2 and 5. So the height is 3. So what does that give me? 33 halves. That's what that definite integral is. So a definite integral, the answer is just a number. Where an indefinite integral, the answer is a function. And eventually we will relate indefinite and definite integrals, just not today. All right. Other things you should know about this idea. If the function is above the x-axis, those y values, which are what we're using to find the area, they're positive. So the area above the x-axis is positive. But if you think about here the y values of the function would be negative, and I had to use the y values to find the area. So if I've got negative values, this area is going to be considered negative. So the definite integral here from 0 to whatever this value is would be negative. So if I consider the definite integral of 0 to 2 pi sine of x dx, go from 0 to pi to 2 pi. This area is considered positive. This area would be considered negative. Well, by symmetry, those areas are equal, so the definite integral from 0 to 2 pi of sine of x dx would just be 0 because they would cancel each other out, those two values. All right. For reasons that you'll see more later, when we change the order of the limits of integration, we multiply the definite integral by -1. So in other words, the integral from a to b of f of x dx will equal to the opposite of the integral from b to a of f of x dx. So do you see how those limits switched, a to b versus b to a? The difference is simply a negative. So this integral from 5 to 2, notice in the last example, or two examples, we did the integral from 2 to 5. So this will be equal to the opposite of the integral from 2 to 5 of x plus 2 dx. But hey, in that example, we showed that that was equal to 33 halves. So this answer would just be -33 halves. So if the bottom number is smaller than the top number, we can just kind of do it normal. What is that area? But when we switch and the bigger number's on the bottom, we're going to have to be thinking about doing the negative, okay, of the area. Okay, let's do another example. Sketch a graph to help you find the definite integral from 0 to 6 of -x plus 2. Let's see, 0 is going to give me 2, 6 is going to give me 8. Okay. Sorry, I guess I'm talking to myself. All right, so here's 0, 1, 2, 3, 4, 5, 6. If I plug, again, this is my function right here that I'm graphing. So I'm graphing f of x equals -x plus 2. So it had a y-intercept of 2, a slope of -1. So using the slope of -1, I know it would cross the x-axis there. If I plug 6 into that, I have -6 plus 2 is -4. Down here, this is the 0.6, -4. So that's the function between 0 and 6. I am interested in the area between the function and the x-axis. And since it crosses at 2, I will find the area of these two distinct shapes and then add them together. This is just a triangle, height 2, width 2. So this has area. The area here would be just 1/2 the base times the height, so it would just be 2. And notice it's above the x-axis, so it's positive. Now this triangle, that area is 1/2. The base is 4. We go from 2 to 6, that's 4. The height is here, which is 4. I can think of it as -4 if I want. Again, since these y values are below the x-axis and therefore they're negative, and I'm going to use y values to find area, I'm going to call this area negative. So I can just think about it, hey, I need to do a negative. So that's going to be -8. So the integral from 0 to 6 of -x plus 2 dx is 2 plus -8, and it's negative. The answer is -6. All right, example 5. Got a few other problems here. Notice it says evaluate using geometric formulas. Again, we will eventually tie this to indefinite integrals and we'll use integration to find these definite integrals. But for now, we're just graphing and using area formulas that you learned in geometry class. All right, the integral from 3 to 7 of 6 dx. Okay, so my function is just f of x equals 6. So hey, that's just a horizontal line. And my limits of integration right here are 3 and 7. So I will go from 3 to 7. So if I highlight that, kind of missed my 7. Let's try that again. And it's this area. Hey, that's just a rectangle. That's a pretty easy one to find the area of. So the integral from 3 to 7 of f of x dx, the width of that is 4, the height is 6, the answer is 24. All right, 0 to 6 of 2x minus 2. So let's graph that out. And it's going to cross the x-axis at 1. And we're going from 0 to 6. So if I plug 0 into here, I get -2. When I plug in 1, I get 0. And when I plug in 6, 2 times 6 is 12, minus 2 is 10. So this is going to be the point 610. Okay, so that is crossing the axis. So I'm going to have two areas. I'll have this triangle and I'll have that triangle. When the triangle is below the x-axis, I'm going to say that the area is negative. So this area, it's 1/2. The width is 1. The height is 2. Looks like that's just a -1. This area, 1/2. The width is 5. The height is 10. It's above the x-axis, so I count the area as positive. So that would be 25. So that's just going to be, if I can squeeze it in here, -1 plus 25 equals 24. So there's my answer, 24. Okay. So this next one, we're graphing the function f of x is the square root of 4 minus x squared. Some of you might need to think a little bit about what that would look like. If we think about this as y equals 4 minus x squared, square root, then it's y squared equals 4 minus x squared. And if I bring the x squared over, I have x squared plus y squared equals 4. Hey, folks, that's a circle centered at the origin, radius of 2. Okay. Now, since my function is just the positive square root, that means y has to be positive. So the graph that I'm interested in is just the top half of that circle, 2 to -2, okay? And so the integral from -2 to 2, a square root of 4 minus x squared. So it's 1/2 of a circle, 1/2 of pi, the radius is 2. So that would give me 2 pi would be my answer. All right, notice this next one is pretty similar to the problem we just did, except there's a negative sign in front of the square root. So what that means is that y is always negative, so that is the bottom part of the circle. So it's a semicircle, but it's below the x-axis. So this area is 2 pi, but because it's below the x-axis, I'm going to make it negative 2 pi. But it'd be the same area as the area in part C. All right. There's a couple properties of definite integrals that I want to try and get at next. If we compare these two definite integrals, the only difference is that 3. What I'm wondering is, could I take this integral and just multiply the answer by 3 to get this answer? So let's try it. The integral from 0 to 2 of x dx. Okay, so that's just this line here. We're going from 0 to 2. So I'm looking at this area. Just a triangle. It's 1/2 the base times the height, which would also be 2. So the answer would be 2. All right. And now let's look at this one. So that was this. So 3x. So, okay, so the graph is steeper. If we think about it, every y value is 3 times the y value of the other definite integral. If my y values are significant in finding the area because they're telling me about height, maybe I'm just going to be able to multiply my answer by 3. Okay, so I'm going from 0 to 2. All right. And so this value here would be 2, 6. Okay. So the area would be 1/2. The base is 2. The height is 6. 3 times what the height was before. So that would just be 6. So yeah, look at those answers. It is 3 times as much. All right. So the big takeaway here is the integral from 0 to 2 of 3x dx is equal to 3 times whatever the definite integral is of 0 to 2 of x dx. Even more generalized here. Notice I just have a function k, not a function, a constant k that I'm multiplying by the function. So what I'm saying is that the integral from a to b of a constant times f of x dx is going to be equal to that constant times the definite integral of the function of f of x from a to b. That's one of our properties of definite integrals. All right, another property that I want us to get at. What if I'm adding 2 terms in my function? Could I do each definite integral separately and then add them? So in other words, does the integral from 0 to 2 of x plus 3 dx equal the integral from 0 to 2 of x dx plus the integral from 0 to 2 of 3 dx? That's the question. All right, well, the integral from 0 to 2 of x dx, I figured it out up here. It's 2. The integral from 0 to 2 of 3 dx, well, that would just be graphing a line here. We'd go from 0 to 2, so it's a rectangle, width of 2, height of 3, that would be 6. So this answer would be 6. All right, what if I do the integral from 0 to 2 of x plus 3? Okay, so it crosses the axis at 3, slope is 1, I'm going from 0 to 2. Hey, looky here, folks. Right here, I have this. I have a rectangle that's 2 by 3. This triangle is the triangle that I had up here. So yeah, I'm just stacking one function on top of the other. And since I'm looking for area, I can just add those areas. So the answer is yes, I can do that. Um, so my answer for 0 to 2 of x plus 3 dx would be the 2 plus the 6, which would be 8. And the answer here is a big yes. All right. So how are these related? The integral from a to b of f of x plus g of x dx. You can separate it out. You can do the integral from a to b of f of x and the integral from a to b of g of x dx and add them. Okay, so let's use these properties to answer some questions. If you're given this information right here, those 3 definite integrals, we have the information to figure out the answer to all of these. Notice limits of integration here are 1 to 3. So that's the same. This, I just have a negative sign, which is a negative 1 times. I can pull that out of the definite integral, essentially. That's what we saw with that example where I was multiplying by 3. All right, the integral from 1 to 3 of x squared dx, looking here, is 26 thirds. So this will just be negative 26 thirds. Okay, the integral from 1 to 3 of x squared plus x. Hey, I can just do 1 to 3 of x squared plus 1 to 3 of x dx. So if I'm adding terms in my integrand, I can separate them out into separate definite integrals and then add. All right, again, looking up here, this is 26 thirds. The integral from 1 to 3 of x is 4. So I have 26 thirds plus 4, which is 12 thirds. So I believe that's 38 thirds. All right. Looking at this next example, the 3x squared. Oh, I have no x squared. I'm just going to take this and multiply it by 3. So this is equal to 3 times the integral from 1 to 3 of x squared dx. So it's 3 times 26 thirds, so it's just 26. And putting it all together here, I can do the integral from 1 to 3 of x squared. 3 times the integral from 1 to 3 of x. Minus, notice I had the integral of, doesn't really say it, but there's just a 1 here. So 3 times the integral from 1 to 3 of dx. Okay, so 1 to 3 of x squared, that's 26 thirds. 3 times integral from 1 to 3 of x is 4. And minus 3 times 2. So let's see, that's 12 minus 6 is 6. 18 and 26. I'm having trouble adding. That's what, 44 thirds? I believe that's right. All right. Couple more properties. What do you think if the integral from 4 to 4 of f of x dx is? So if I think about the definition, I've got some function here, f of x, but I'm starting at 4 and ending at 4. So I don't really have any area to shade. I just have a line. So that's going to be 0. Just 0. All right. So anytime your 2 limits of integration are the same, the answer's 0. All right, this one's a little bit fancier. I've wanting to know if I want the integral from 0 to 5, could I find the integral from 0 to 3 and the integral from 3 to 5? So in other words, I'm going to break it up right here. Here's the integral from 0 to 3. Here's the integral from 3 to 5. I think it's pretty clear that if I add those two areas, I get the big area. So the answer is yes. Those would be equal. Okay. Now, what if I had the integral from 0 to 5 of f of x dx and then 5 to 3 of f of x dx? So notice here, these limits of integration, the top limit here and the bottom limit here were the same. Same thing. Top and bottom are the same. So would this be equal to the integral from 0 to 3 of f of x dx? Are those equal? Well, if we think about what this means, this is a positive value. It's this entire area, the purple and the green together. Notice here, 5 is less than 3. So since I have switched the limits of integration from the way I normally look at it, which is lower value first at the bottom, this is going to be the negative. So I've got 0 to 5 of f of x dx minus the integral of 3 to 5 of f of x dx. Think about what that means. The whole area minus integral from 3 to 5. That's the green area. Wouldn't that just leave me with the purple area, which is the definite integral from 0 to 3? Why, yes, it does. So the answer is yes. So here's the thing. We don't actually have to know that when I do this, that the values on, like here, they're in increasing order, 0 to 3 and 3 to 5. They don't have to be. As long as these two match up, it works. Those essentially can kind of, I hate to say it, sort of cancel out. And then you'll be going from this lower limit to this upper limit. It'll always be the case. All right, so short summary here of what we've learned. If you were doing upper and lower limits of integration the same, the answer is always, that's right, 0. If f is integral on a to b, then we define the integral from a to b of f of x. If I switch the limits of integration, notice that's the difference. Instead of a to b, b to a, you got to put a negative sign in front. All right, if f is integral on the 3 closed intervals determined by a, b, and c, these match up, so it'll go from a to c. I don't have to know that a is less than b is less than c. Doesn't matter. And if I have a constant in the integrand, I can just put that out in front of the integral sign. Just multiply the integral of f of x by k. And if I'm adding or subtracting functions, I can do each definite integral separately. So I can find the definite integral of f of x and add to that the definite integral of g of x. All right, there you have it, folks. Those are the highlights of lesson 5.2. Hope it makes some sense. Let me know if you have questions. Bye, folks.